or anything else that doesn't involve the quantity of matter or mass, the presence of those things within the space between the Earth and the Sun is ignored by the law of universal gravitation, and therefore does nothing to interrupt the dynamical relation between the Earth and the Sun. Therefore, to say that there is a distance between the Earth and the Sun is not to assert that there is a vacuum between them. It is merely to claim that they are at what we might call a dynamical distance. If you like, they occupy a dynamical vacuum, for there's nothing massive between their spatially separated centers. As a technical notion, impressed force is intertwined with a technical notion of distance, or so I claim. Now, let's consider the notion of a substance and its action. That's the metaphysical notion. From Newton's point of view, to say that one substance acts on another is to say something that is sensitive to the discovery of a medium between the Earth and the Sun. Take the following example. Suppose there is a non-massive medium between the Earth and the Sun, a non-material medium, because, by the way, mass is essential to matter according to Newton. So when he says not material, it would be not massive. Suppose we discover a non-massive medium between the Earth and the Sun, one that somehow transfers the action of one substance to the other. In that case, it would still be correct to assert that gravity is a distant action, or force, between the Earth and the Sun, because the non-massive medium, as I suggested, is irrelevant for the question of the force. But that's not the case if we're focused on the question of whether one substance acts on another at a distance. For if the immaterial medium between the Earth and Sun were discovered, it would indicate that the Earth, let's say, transfers its action through the medium to the Sun. Of course, that would mean there is no action at a distance between the Earth and the Sun. Remember that we're dealing with an instantaneous action. If you're wondering, well, how does this medium work? It's instantaneous, and that isn't a problem for anybody. At the end of the 17th century, that becomes a problem later. Another way to put this point borrows some language I introduced a moment ago. In Newton's theory of gravity, we have a dynamical conception of distance, such that two bodies are distant given their spatial separation and the lack of anything massive between them. But in traditional metaphysics, we have an ordinary conception of distance, such that two bodies are distant given their spatial separation alone. The non-massive medium does not disrupt the application of the technical concept of distance because of its dynamical irrelevance, but it does disrupt the application of the second conception. There's another way to distinguish forces as causes and agents as causes. So let me add that now. We know from the metaphysical tradition, and indeed from way back into medieval metaphysics, that each and every action must be attributed to some substance. As Newton himself says, action cannot subsist without substance. You can't have an action, something happens, without some actor that did it. Something's got to do that, according to the metaphysical notion. Now, this is a vague idea, and it gets elaborated in many ways, but that's already enough to distinguish it from impressed forces, especially those of the centripetal variety, like gravity. For Newton argues that his theory does not require us to think, and indeed does not license us to think, that gravity is the property of any body, or of material bodies generally. Let me explain. First of all, Newton certainly thinks that gravity is part of nature. In my favorite line in all of Newton, he says in the General Scholium, "Et satis est quod gravitas revera existat." It is enough that gravity really exists. Secondly, Newton thinks, in addition to that, that gravity is universal. All material bodies gravitate toward one another. He contends, thirdly, that the law of universal gravitation indicates how to measure gravitational interactions. But fourthly, he denies that we have sufficient knowledge to understand gravity through any particular physical model. We don't know whether there's a medium for gravitational interactions, and if so, what properties it might have. So to say that the Earth and Sun interact gravitationally is to say something along the lines I indicated before, but it is not to commit yourself to the idea that they exchange particles or waves, or there's some medium between them, etc. We have no knowledge of what he calls gravity's physical seat. Newton also wishes to deny that any physical interpretation of gravity that entails action at a distance among material bodies, he wishes to deny any physical interpretation of gravity that entails action at a distance among material bodies. So in the letter to Bentley, he says, he wants to deny that gravity is innate, inherent, or essential to matter on the grounds that endorsing that view would commit us to action at a distance. Here's why. If gravity were an essential property, then clearly it would not be dependent on a medium, because you could take it away, it's part of it, and therefore to exist even in the absence of a medium. That would mean material bodies act at a distance on one another. Here we are talking about the actions of substances and not merely of the force itself. But wait a minute, you might say. How can Newton tell us that we can measure gravity using the law of gravitation even while remaining ignorant of gravity's physical basis? How can we measure anything without knowing what it is physically? I'm going to give you an analogy here that hopefully will help explain this. In the past, and I'm getting close to the end, I know I'm probably almost out of time. In the past history of science, many people were in a position to say that they could measure the temperature, say, of a room without knowing what temperature is. So they could say, for example, with the thermometer, it's, I don't know Celsius, so I'll say something crazy. 25, is that all right? Okay, 25, it sounds crazy to me, but let's say it's 25, a little bit more, 20. Let's say it's 20 degrees in here, 21 degrees in here right now. That claim that we can measure the temperature wouldn't commit someone to the idea that the air in this room has a particular property, or that there are tiny corpuscles in the air moving in such and such a way, or anything else. You can measure temperature without knowing fundamentally what temperature is. And it took, of course, quite a long time to figure out what temperature amounts to. Newton has a similar situation. He says that we can measure gravity, which is an action, and like temperature, it can cause things. So the temperature in the room could cause you to sweat, presumably. You can make that claim without knowing what temperature is. He tells us we can measure gravity, the interaction of material bodies, without asserting that gravity is a property of anything at all. For Newton, his theory does not license the conclusion that gravity is a property of material bodies, or indeed of anything. That goes beyond our knowledge. Okay, for the conclusion, just a couple more minutes. Let me draw two conclusions from this episode. First, we can conclude, I think, that there is no tension in Newton's views after all. He can have his cake and eat it too. He can simultaneously assert that gravity is a distant action in a technical sense, even while denying that any substance acts at a distance. As the letter to Bentley suggests, Newton thought that some agent must ultimately be responsible for gravity. And he speculated at various points in his career that God might actually be the agent in question. Suppose for a moment that God is the agent. Then according to my interpretation, the following would be the case. Gravity would be a distant action in every case in which two gravitationally interacting bodies are at what I have called a dynamical distance from one another. But no substance would act at a distance, because the actions of all substances that interact gravitationally would be mediated by God, who, as you recall, is substantially omnipresent. Keep in mind, the cool thing about God is God is present not only at the surface of the earth, but throughout the entire earth. That helps understand, well, how could gravity, as he says earlier in the General Schooling, how can gravity go, as it were, right to the center of a body, where the center is what's important about it, and not, well, God can do that. Here's the second conclusion, or it's sort of a philosophical moral of my story. If you like, in his causal reasoning, Newton was a revolutionary physicist, but a conservative metaphysician. As I say, when it came to substances, even the infinite substance, Newton had a very traditional picture of causation that goes way back through the medieval period that really is wedded to ordinary ideas about causation. But the key to future developments in philosophical and scientific understandings of causation is that Newton very deliberately insulated the aspect of natural philosophy that we would call physics, which centers on discovering the forces of nature, from the aspect of natural philosophy that we would call metaphysics, which centers on substances and their actions. Remarkably, this is, I think, the most remarkable thing, Newton insulated physics even from his own fundamental metaphysical preconceptions about how actions must be attributed to substances. That insulation enabled physics in the 18th century to proceed on its merry way, even as it developed concepts and conclusions that greatly challenged the very heart of the metaphysical tradition. Thank you. However you like, sure.
Okay, so we're ready for questions. If you could catch my eye, I will. Yeah. Go ahead.
Thank you. That was very interesting, and I'm completely swayed on that front. I'm just curious what your opinion is about those early writings of Newton, in which I think, perhaps you might say by a parallel kind of argumentation, he opposes the mechanical philosophy. And I'm thinking of the theory of collisions in the Waste book, in which he invokes the existence of what would have been, from a mechanical philosopher's point of view, completely inadmissible entity, and that's a vis elastica. An entity that can even operate in perfectly hard bodies, although in other cases it might involve actual finite compression, say of two balls sort of colliding with each other. Without going into the details, his addressing those sorts of problems actually had a very profound effect on the whole notion of impressed force, because the elastic force itself, particularly in hard bodies, doesn't have any sort of kinematic displacement. There's no extensive magnitude applied to it. And indeed, using the impressed force as reflected in the new motion that a body might have after having an elastic force applied to it, gives you, for the first time, a measure of a quantity which is purely intentional. So the irony is that this parallel line of argument says he's ditching mechanical philosophy, can I say, at the very point of contact, because he's demanding that there be a non-mechanical account of the processes of impact that are central to the mechanical philosophy.
Yeah.
So he has already, by the time he's finished the Waste book, deserted the mechanical philosophy, and long before we get to actions from distance.
Yeah, that's extremely interesting. I hadn't made that connection, and I'm glad you pointed that out. I think you're absolutely right that he was never a completely committed mechanist, although he read Hobbes and Descartes and, of course, Boyle very early when he was an undergraduate at Trinity College in the 1660s. He, I think, was never wedded to their notions of causation. And of course, we were speaking about this earlier today. Depending on when you think he wrote De Gravitatione, this anti-Cartesian tract that was never published during his lifetime, but clearly was written by Newton at some point. Some people think that was quite early, some don't. But he clearly was never a committed Cartesian, which is a non-trivial thing. So what happened with Henry Moore is particularly salient, because Henry Moore was, it seems, a committed Cartesian early in his life. And then he started to have questions about Cartesian mechanism. And he raised these issues in 1648 and 9, right at the end of Descartes' life. It was right before Descartes died. But Henry Moore was much younger. And Moore slowly realized that he needed to avoid thinking in purely mechanist terms or Cartesian terms. And that had a huge impact on many thinkers in England later, including Newton. So Newton had gone to a grammar school where I believe one of the teachers had been Henry Moore's student. He knew about Henry Moore from when he was very young. Anyway, Newton was not like that. He was never a Cartesian, full-blooded Cartesian as far as I know. And I think you're right, you're giving more evidence that he was not a fully committed mechanist even early. He certainly was willing to use the notion of a force in very creative ways, from the mechanist point of view, in very problematic ways, beyond what you were getting in other thinkers. And then, of course, as you say, later with impressed force, he's really completely rejected the mechanist, let's say, strictures on what we could say about causation. I could go on and on about that probably, but I probably should let other people ask questions.
So, Chris?
Yeah, just a clarification right towards the end. I didn't follow the step. If Newton recognized that you weren't going to have action at a distance, why doesn't it follow that distance in your technical sense would require a medium? Because I thought at one point you said he was totally not committed to sort of the metaphysics of it and how things really wasn't an essential property of matter.
Right.
But you know, if we just take the Earth and the Sun, doesn't it follow that? You know, I mean, I like your interpretation that he probably thought it was God that was the substantial medium between them. But why doesn't it sort of follow as a consequence of the view, if you're going to reject action at a distance, that there has to be some medium or other? And you seem to open up the possibility that he wouldn't even say that. And I didn't follow why it doesn't just follow.
I see. Well,
that quote about the Bentley thing about the different kinds of things.
yeah.
Or the thing from.
Well, I think we do need to distinguish between what he says about the force and what he says about substances. So I believe he's committed to the idea that action at a distance between substances is inconceivable,
right,
and an absurdity. So certainly he doesn't want any interpretation of his theory that would entail that must be occurring.
Right.
However, the theory itself is compatible with, that is, what you say about the force is compatible with there being a vacuum.
Okay.
It's just, you see what I'm saying? It doesn't rule out
Right,
one thing or the other.
Yeah, so what I kind of missed was, but it seemed that other considerations required then, so from a physics point of view, action at a distance in a vacuum is completely compatible, but other considerations, namely about substance, would suggest that there still had to be a medium.
Yeah, right. So if you have these two causal notions, one is the notion of a force, and one is the notion of a substance acting.
Yeah.
Then you have very different questions. With a force, it's perfectly possible that you can apply it to bodies that are in a vacuum. That isn't a problem. And it's also possible that there could be any medium you want, as long as it's dynamically irrelevant. I mean, you know, so people often say to me, well, what is this crazy medium that is not material? And I try to say, well, look, first of all, one has to keep in mind that he is talking about something that doesn't have mass. That's the key. It has no quantity of matter, right? So it doesn't resist acceleration. You can push it all around. And it has no weight toward any other body, if you want to speak kind of loosely. But it could be physical in many other senses. There's plenty of things that might lack those two features. So it isn't necessarily a spooky, kind of crazy idea. It could be physical in many senses of the word physical. It could be things with extension, size, shape, motion, but they lack these two key features. It's still a very puzzling issue. But I think the key is, what does the theory commit you to? What does the application of the notion of a force commit you to? And then, what are you committed to in metaphysics? And I think you can sort of have your cake and eat it too.
Right.
In that way. Yeah.
Okay, thanks. That's helpful.
Okay, so I think Ryan is next.
Hello, thank you. I've enjoyed your talk very much. I think I agree with pretty much everything you've said. And I like your resolution of the tension at the end. As you might expect, my comments about the very last conception of cause, what you've called, I believe, agent causation. And comments simply this. Submit a comment for further comment. Why call it agent causation at all? Isn't that just likely to antagonize someone like me, for instance? Why speak of agency in any sense? Why not just stay more squarely agnostic, as Newton does himself, with some other labels? So my point is that what might seem like a quibble about words, but maybe something else, why not adopt a more modern vantage point where we might conceive of the gravitational interaction Newtonian theory in terms of conditional. It's conditional quality, and furthermore, it's counterfactual quality. It doesn't. So take our Earth-Moon system and say we have a little satellite going around the moon. It doesn't matter if there's actually a satellite there or not, but if there were one, we know there would be an inverse square force such that that satellite around the moon would stand in that interaction with, say, the tip of my pinky.
Right.
Why, I mean, agency, sure we can open the extension of the concept such that it admits it, but why not stay more squarely agnostic?
Well, just to be clear, I'm not sure I understood your question, but if I did, I didn't intend to be using the notion of agent causation to talk about the Earth and the Sun. There we're talking about forces, which I take to be a technical notion, and so we are not dealing with agents or substances at all. Right? We're not in, as it were, a metaphysical context. In a metaphysical context, you know, a material body like the Earth or like me would be a substance, and there's other kinds of substances, right? So, for example, if you're wondering, by the way, about what does Newton think about the mind, you might wonder, given what he said about God, the mind is extended. Henry Moore certainly had the same view. It was because of Newton's dissatisfaction with Cartesian metaphysics, by the way, that he thought you really have to think of the mind as extended. It has to be located in space. Why? Because it acts in space. It acts in a particular place. The mind, you know, I can wiggle my finger. Well, okay, there's got to be a substance that's doing that where it occurs, so my mind has got to be present here. And that's why I can't wiggle something in London. Well, I can in London. I always use London as a faraway place. Paris. I can't wiggle something in Paris. Anyway, because my mind is located here, not in Paris. Leaving that aside, so the agent causation is restricted to the metaphysical context. It isn't employed in what we would call the physics. It's not necessary at all to think about that with forces. Right.
Yeah. Okay, Henrik and then Bill.
Yeah, thank you very much. I like that a lot. I especially like the distinction you get to towards the end between the physics and the metaphysics. The way I tend so like to see the development of science in this tradition is that it starts with metaphysics, and then physics and metaphysics are very much tied for a long time. And it's interesting that you get to the point of Newton where you get this separation, which I guess is the step of making physics sort of more modern, more contemporary. So that's just a comment. The question I would like to is about agent causation as well. And I was wondering, what does this? I mean, agents causing and God causing as the cause of gravity is. We tend to. I mean, it's natural to think of agent causes as free causes. I don't know what Newton thought about that, but that has implications for how you see, I guess, the necessity of these things. Do you have something? What would you say about that?
Yeah,
of course, it relates to Descartes as well, which has very specific views about that.
Yes, that's an extremely good question, because agent causation does, certainly in this context, imply that it's free cause. But of course, we can take a pen to be a substance. From Newton's point of view, pen is a substance. My mind is a substance. God is a substance. But that wouldn't really apply in the case of a pen. So it might be better just to say substantial action. So we're talking about the actions of substances, whether free or not. Agents, you're right. It restricts it more and it implies something. Here it's difficult because, although I have not read every word Newton ever wrote, I don't know if anyone has ever done that because there's so much. As far as I know, however, Newton never really addresses that question about, how do we understand God's relation to the laws, for example. This is, of course, a subject for Descartes, And Newton knows, Descartes thinks you derive the first two laws of nature from God's immutability, that sort of thing. And he's perfectly well aware that people have views about God decreeing certain laws to be the case. But as far as I know, he doesn't really give any provide any substantial discussion of God's relation to the laws of motion, such that we can really answer this question. So, Leibniz or Descartes has a long discussion. Leibniz, of course, with possible worlds and the principle of sufficient reason and so on. I don't think Newton has any strongly developed view of, as it were, what the laws of motion tell us about God's sort of choice of the actual world or creation of nature or anything like that. I don't think he has any view. And when he's silent, it's significant because, as I say, he read authors who did address this issue, but he did not want to. Of course, he thought we had an empirical warrant for the laws. We treat them as axioms. Axiomata sive leges motus. A lot of people always forget that. We just call them laws, Well, no, but they're it's also important that he says they're axioms, so we're going to treat them. But what's our warrant for them? Well, it's an empirical warrant. We certainly don't derive them from the property of God, like Descartes. Although, did he actually think, if these are laws, God set it up? Yes. In the Queries to the Optics, he says that, basically. And he says something like, if God had chosen to make things fundamentally different, if he had chosen to make matter different or something like that, we could have different laws. He says that in the Queries. A standard sort of view, but there's no richly developed view like you get in Descartes or Leibniz along those lines. But I think you're right, it would be better to call it substantial action and not agent, or substantial causation and not agent causation for that reason.
So, Bill?
I guess I want to read out the third law of motion here.
Okay.
To any action, there is always an opposite and equal reaction, semicolon. In other words, the actions of two bodies upon each other are always equal and always opposite in direction. So notice it's bodies acting on each other. And the third law of motion, and of course the key step in the argument for universal gravitation, is applying the third law of motion to say the weight of Jupiter toward the Sun and the weight of the Sun towards Jupiter. These are equal and opposite reactions, given Jupiter's orbit and the tiny, whatever we look like it. But the important thing is, it sounds to me like, for your story, the bodies here, first he says their bodies can act on each other.
Oh, yes.
When you're applying the third law of motion, and he definitely applies it to those, as we all know.
Yes.
So they're Jupiter acting on the Sun and the Sun acting on Jupiter.
Yes.
Now, all that is, in your version of it, that's being separated from the substance story.
Exactly.
I like that very much.
Exactly.
That's okay. And so the sort of thing, there might be so when he's committed to applying the third law in this way, he can claim not to be thereby committed to action at a distance, even though he's using action here.
Exactly.
Okay, and your idea is, they're not being treated as substances in this. The action thing can be separated from the substance thing.
Yes, exactly.
Okay.
Because.
Okay.
Or am I interrupting you?
No.
Because. That's exactly it. Because in definition 4, impressed force is the action exerted on the body to change its state. So, and it even says, interestingly, the force consists solely in the action and does not remain in the body after the action has ceased, right? We all know it. So there, and that already is, whoa. So you're really not thinking of that force as a property of the body, right? Yeah, it's exerted on it, and it is the action. So forces are not properties in the kind of traditional metaphysical sense. They are actions, but it's a technical notion of action. So everything you said about the third law is exactly right. It doesn't commit him to action at a distance between material bodies. There is an action across space, or an interaction, you can call it. But that doesn't mean that one substance is acting on another. That's a separate notion of action.
Okay, we have a question from Corey, and then we'll go to online.
Okay?
Just a curiosity, really. So in the Latin that you provided here, from the general scholium to the colon, it reads down here is sine substantia, etc.
Yeah.
So I guess my question is, why is Viavis translated as power there rather than as rather than as force? I mean, is Newton using a different term here than he's used for force all the way through?
Good question. The only reason is, well, force would be vis. The only reason is just to not think he's talking about, impressed forces or something. Vis impressed, yeah. So you can call it that. There are several translations. I forget what Châtelet has. So Emily de Châtelet did the French translation. I have it here somewhere. Don't I?
Yeah,
Oh, yeah.
Here, it's right there at the bottom of the board.
Right before the reconstructed argument.
Oh, but did I give?
It's on the board. It's all over there.
Thank you. Yeah, so hers is, not solely virtually, but substantially. The problem is if you, and I think that's what Andrew Mott had, the first English translator from the virtually, which meant something different in, the early 18th century than it means to us. We think, oh, virtual, that means it's not real or something. So that's why I didn't say virtually there. But it was just to avoid these kinds of confusions. That's all.
Okay, now we'll go to our virtual questioners.
Virtual questioner.
Okay, so this is from Kirsten Walsh at the University of Otago in New Zealand.
Okay.
She asks, how does Newton's non-massive medium fit with his idea of non-resisting ether?
Right. Well, I deliberately avoided the question of the ether. That's a very good question, because that raises all kinds of other issues that were not directly relevant. So I just left it open. And as some people probably know, Newton speculates about whether there is an ether at various times in his life as a medium for various kinds of phenomena. And sometimes it looks like he thinks maybe we can detect an ether. Sometimes he thinks we can detect that there isn't an ether. But I didn't want the medium and the ether to be identified, because even if he eventually thinks there definitely is no ether, it's a certain kind of medium. But that would leave open any number of other media. And of course it leaves open God as the ultimate agent underlying causation. So that's the reason to leave it aside. But certainly some of the things he says about the ether, about whether it resists motion, etc., would be relevant for thinking about what kind of medium could he be allowing for the case of gravitational interaction. Hopefully that will be an answer, I don't know.
Is there another?
There is one more online question. Just 1 second here. This is from Joel Brown. Sorry, just a second. So Newton tells us that mass is an ordinary intrinsic feature of material bodies, and this is a property which pertains to resisting change from other bodies, gravity, inertia, etc. It seems rather that mass is not ordinary, but is actually God's acting on God's acting on a body in such that it is attracted to other bodies such that it follows some particular mathematical model. But this doesn't appear to attribute the feature of mass to material bodies. So we'd like you to comment on that.
Well, he definitely attributes mass to material bodies. And he actually tells us in, for example, Rule 3, I think Bill's favorite rule, added to the second edition of the Principia, that mass is an intrinsic feature of a body, and he says it's essential to matter. So it's easy to miss the significance of that, but if we think about what was going on in the 17th century with the mechanical philosophy, if you think about Locke, or Boyle, or Hobbes, or Descartes, or even Galileo earlier. Galileo's a little different, but anyway. It is remarkable that people thought, look, a rock has got a size, okay, it's got a shape, sure. You can't have a rock in my hand in the same place at the same time, so it's impenetrable or solid, depending on which, right? That's about it. Maybe number or something. But Newton says, well, that doesn't matter. He actually thinks the mechanists are not talking about matter. Why? Because matter resists acceleration and will have weight in the appropriate circumstances. So a Lockean body, what Locke calls a solid extended substance, is not material from Newton's point of view. That doesn't mean it's some spooky, crazy thing. It just means, this is how I read it, if you had a Lockean body, if you know what I mean, it's true that you couldn't have two Lockean bodies at the same place at the same time, but if you bumped into one, anything could happen. As long as it resists being in the same place at the same time, it can just accelerate as it were arbitrarily, because it doesn't have the quantity of matter. So anyway, Newton thinks that they really don't have matter in their sights. They have something else, something that's not fully material. So Newton certainly thinks mass is essential to matter. The thing about God, it's tricky. He certainly thinks within natural philosophy, when we're doing what I'm calling sort of the technical work of the Principian forces, we attribute mass to bodies. There's no problem there. We find a way to measure the quantity of matter. That certainly doesn't involve God in any way. If you look at the queries to the optics, I think especially query 31, the last one, there's some speculations there about this very issue. Certainly he thinks God could have made the world to be different than it is, and I think I said this before. He says something like, well, God could have made particles with different properties than the ones that we have in our world. Matter, would it be matter or something else? That's sort of speculative, but there would be different laws. So certainly he thinks ultimately, God did choose to do that, but you certainly are not committed to any particular view about God just by saying bodies have this quantity of matter. That's, I think, not true.
There seemed to be another job that in that question. I mean, this role of mass, the inertia, source of inertia, is clearly for Newton essential. But of course, one of the things that these applications of the third law of motion are allowing is you measure the mass of the sun by looking at orbits about it. And so we can think of that as the active role of mass. And that's the one that requires all this stuff. And the question was kind of, I thought, I hope, that it was talking about both of those things. And I think the story for the first one is, for Newton, clearly that's essential. And the second one, clearly it's not.
Mm-hmm.
Okay, and so I think it's important to
Yes, thank you, yeah.
I'm going to abuse my position.
Okay.
So I think there's a sense in which the gap that opens up between the mechanical conception of causation and the conception that's more quantitative and abstract that comes with Newton's conception of force is quite a bit bigger than you suggested. It's not, I mean, I agree with you that there's, well, I think you agree that there's an important step that Newton makes. I just think he goes a bit further. And I think there's a sense in which it's hard to see how forces, attributing forces, even though he says they're actions, are causal in a kind of direct sense, like the mechanical picture of billiard balls colliding. And these are the sorts of problems that led Russell to say there's no notion of causation in physics much later, partly because you have relations of simultaneous relations between quantities specified in equations, and it looks like the level at which you can apply something like a mechanical causal notion is more like solutions to the equations describing particular systems as opposed to describing them to the forces themselves. So that's just a worry that there's more of a gap that's introduced there. And so thinking of forces as themselves causes is a little problematic.
Okay. I'm glad you asked that. So we might disagree on that. I don't know.
First of all, it's not to deny the reality of forces in the sense that Newton wants to.
Okay, but there's more than that. That's that Russell paper. I happen to think Russell is not right about what Newton thought he was doing in his physical theory. Now, it may very well be true that later formulations in the 18th and 19th century, you can dispense with this notion of an action. It's some vague idea people have because they bump into things, but forget all that. We're going to do very fancy mathematical physics. We don't need that idea. But I don't think Newton believed that myself. Here's two reasons. First of all, because I think he did want to assert what I would call the reality of force in many ways. He certainly thought gravity really exists. That's a very substantial claim, as against, don't forget the, you know this, but I'm saying, in general, the second edition of the Principia where he rewrote a number of things, added things, was in reaction to all these fundamental criticisms from various mechanists. You know, there was a heavy debate with Leibniz at that time. And he wanted to assert, as against sort of instrumentalist, as it were, to speak anachronistically, reinterpretations of the physics in response to mechanist criticisms, that he was not endorsing that, and he thought gravity really exists. But if you think that's not enough, there's more.
Right, well, so what I was, I think we agree. Partly what I would say is the language of causal ascriptions is perhaps not the right way to characterize. I mean, it's partly what you mean by cause.
I'm going to borrow this, is that all right? Let me just say, there's also, leaving that aside, Newton, I'm cheating here, but Newton corresponded with Leibniz directly. Almost nobody really ever writes about that very much because of the Leibniz-Clark correspondence, how important that is.
This is in the 1690s.
1693, exactly. Newton and Leibniz corresponded directly. And let me just tell you what happened. So Leibniz
urges him to speculate and he doesn't take him up on it.
Well,
No, wait.
No.
It's not smart.
I'll tell you. Right. Leibniz certainly is not happy with what happens in the Principia with gravity, obviously. He thinks there's a problem. Newton says, however, I just want to see if I can, yeah, here it is. He says, this is Newton writing to Leibniz, 16 October 1693, directly, so not through Clark at all. That was much later. Since all phenomena of the heavens and of the sea follow precisely, so far as I am aware, from nothing but gravity, acting in accordance with the laws described by me, and since nature is very simple, I have myself concluded that all other causes are to be rejected, just gravity, and that the heavens are to be stripped as far as may be of all matter, etc., etc. I am your most sincere friend, and I value your friendship very highly. Farewell. Okay, so I think, so even when writing directly to Leibniz, who had been criticizing him on this exact set of issues, Newton says, gravity is the cause. It acting alone is enough when we're doing, physics, right? This is exactly the same time he's writing to Bentley. So it's not about the metaphysics, it's about the physics. Gravity alone is enough. All other causes should be rejected. I think he's strongly committed to the idea that if you want to know what causes the moon to, orbit the Earth, it's gravity. It's not Leibniz's theory of the vortices, and it's not Descartes' theory, and it's not any other theory. Gravity acting alone does it. So I think it's a strong causal notion, and I think it is an essential feature of what he at least takes himself to be doing, which is compatible with what happens. Later maybe you can. I mean, of course, we can see how it becomes more technical, more abstract, getting further and further away from fundamental notions, maybe. But I don't think he was willing to give up on the notion of a cause, and I think he thinks the force is it.
Somewhat talking past one. I mean,
okay.
I'm arguing that the notion of mechanical cause that you said he distances himself from, he goes further.
Right.
And that, I mean, I take him to be saying, as in some of the passages in the General Scholium where he says he doesn't know the cause of gravity. What he means is, in that context, he doesn't have a hypothetical explanation of gravity or an identification of the physical source of gravity.
Right.
So cause is used in a particular sense there.
Exactly.
In the passage to Leibniz, I don't see why you couldn't, I mean, in that sense he's saying there's no other force that's needed, or perhaps no other cause in the mechanical sense, or, that's how you're reading.
Well, he doesn't, that's true, he doesn't.
But in any case, I've abused my position.
Okay.
So please join me in thanking Andrew for a really good talk.